Page 5. This top part of page 5 is some questions I took from Alex, with their permission, of course. We're supposed to look at these four graphs. Notice the coefficients labeled A, B, C, D to make it easy to tell which one's which. And then answer these questions below, categorize them sort of. So, first part says, for each coefficient, choose whether it is positive or negative. Remember, the multiplier of the square term is positive if the graph opens up, negative if the graph opens down. So this first question is pretty easy, and you'll have a pull down tab like that when you're on Alex. But A is positive. I'm just going to put a P there, positive. B is opening downward, so it's negative. And C is opening up, so it's positive. And D is opening down, so it's negative. That wasn't so difficult. This requires a little more thought. Choose the coefficient closest to 0. So if you think about a number being close to 0, we'll go back to a number line idea for a moment. 1, negative 1. Further away from 0 in either direction, the number has a larger absolute value. Closer to 0, you get numbers like a half and a third, negative a half and a third. Well, how are you supposed to tell that from this graph, this collection of graphs? Remember when we talked about the A doing a vertical stretch or a vertical shrink? The smaller the value of A is, the more, just for comparison, see, if I was looking at these three graphs all together, this would be the one with the smallest A value because it's the one most spread out. So looking at all four of these at once, which one appears to be, for lack of a better word, the widest? My money's on C. See, this one's pretty pointy. That's probably got the largest absolute value coefficient anyhow, if you disregard the sign. So closest to 0 would be choice C. And the coefficient with the greatest value, and greatest value means, if we line the numbers up in order, which one's the biggest number? Well, I'm going to disregard the negatives. They can't be the largest. It's got to be one of these two. These are both positive. And this is the skinnier or more vertical stretched graph, so this has a coefficient that has to be larger than C for that reason. So our choice for that would be A. Last thing, we want just to get our thoughts connected. Here's a quadratic function in factored form. Can we use this factored form and do a few things and maybe get a pretty decent graph without resorting to making a table? Oh, remember we talked last time, I think it was, about x and y intercepts. If you put in 0 for the y value, you get the x intercepts. When does this equal 0? At 8 and at 2. Y equals 0 at x equals 2 and at x equals 8. Okay? And if we put in 0 for x, that'll give us the y-intercept. If we put in 0 for x, this will say negative 8 times negative 2, which would be positive 16. 2, 4, 6, 8, 10, 12, 14, 16. Gee, what a funny coincidence, 16 boxes worth of room. Now, what about finding the vertex? Well, remember when we were drawing an axis of symmetry? This point right here, that's exactly halfway between those two x-intercepts. When we get done, the graph is going to be symmetric, meaning these x-intercepts are going to be equidistant from that axis of symmetry. Another thing I could say here is just take the average of 8 and 2. What's the average of 8 and 2? 8 plus 2 is 10. Divide by 2, you get 5. 1, 2, 3, 4, 5. That's the x value of the vertex. How can I get the y value of the vertex? Plug in 5 back here. If you plug in a 5 for x, 5 take away 8 is minus 3. 5 take away 2 is positive 3. Multiply those, you get negative 9. So 2, 4, 6, 8, 9. And now, if we wrote this out in that other form, you know, if we multiplied this out and changed it to look like this, do we believe that the a number would be a positive 1? It has to be, because there's no coefficient in there. So starting at the vertex, go over 1 up 1, and then go over 1 up 3, and then go over 1, 2, 4 up 5. See how we're landing right there? That kind of confirms that that idea is working. Over 1 up 1, over 1 up 3, over 1 up 5. Hey, what's next? Over 1 up 7. 2, 4, 6, 7. And then over 1 up 9. 2, 4, 6, 8, 9. Look at that. Isn't that enough to restore your faith in something or other? So we got all this information just by starting with x and y intercepts. Plug in 0 for x, solve for y. Plug in 0 for y, solve for x. Get the y-intercept, the x-intercepts. Use the idea of symmetry. And then that 1, 3, 5, 7 counting pattern going out from the vertex. And you get a lot done. Anyhow, hope that helps. End of page 5. Take care.